Okay, so we're going into module 4 for this last session. Again, the use of this session of the information that is presented is protected by copyright laws. Again, these are cue points which are expounded upon verbally, and you need to make sure you go back to the code and to read the literal words and specification of the codes, and then reference to the standards that the code refers you to other code sections that code references that the code statement provides you in order to make sure that you're applying the proper code provisions for your actual project conditions. So what you're learning today is to be used with applicable codes and standards, and it is information that's help you navigate the Part 9 of the 2015 National Building Code. So in Module 4, we're going to look at structural provisions and energy efficiency provisions of the Part 9. As always, we refer back to Volume 1. So when you're looking at part 9, you're never using the only Volume 2 of the building code. You use both Volume 1 and Volume 2 because the Division A, it applies to all buildings. Acceptable solution of Division A in Part 1 is actually applies to all buildings. Some of the provisions, as we have seen earlier this morning, in Part 9 refer to provisions of Parts 5 and Part 7 and Part 6, and Part 3. So make sure that you have both volumes handy. We have seen that we use the climatic and seismic information from Appendix C. And we know that Appendix D applies to fire resistance rating of structural elements, and it can be used for Part 3 or Part 9 buildings. And Division C applies to all buildings. Division B Part 9, which is in Volume 2, that's where we're working today with in structural provision and energy efficiency provisions. As always, we look at compliance, the terms and abbreviations, reference documents, applications, climatic seismic data, referenced documents and organizations. We reviewed them this morning. We looked at material systems and equipment. Some of the provisions relate to concrete, lumber and wood products and metals, the specifications that they need to meet to be used under Part 9 buildings. Looked at the structural requirements, the structural design requirements, applicable limitation, design loads, deflection, and foundation conditions under 9.4, which we're going to see first. There's provisions related to glass and loading of glass. We have looked for, we'll be looking at also when we're looking at energy efficiency, we're looking at windows, doors, and skylights. Structural provisions also impacted by excavations, footing and foundations, the columns, floors on grounds, masonry, insulating concrete form walls, not in contact with the ground, wood frame construction, steel frame, wood stud construction. So we have also, we'll cover also energy efficiency under 936. And we will do a slight revisions of the objectives and functional statements and alternative solutions. Note that the span tables and the fire resistance and sound resistance tables at the end of Part 9 are applicable only to Part 9 buildings, all right? So these are a part of Part 9, part of the prescriptive provisions that you can use for assemblies and for design of Part 9 components and assemblies. Okay, so for structural, for what was that? For the structural provisions, I highlighted for you here some of the definitions pertinent to structural design, so this is basic terminology. Dead load is the weight of all permanent structural and non-structural components of the building. Live load is a variable load that, due to the intended use and occupancy, it is assumed to in the design to the structural member of a building. It includes loads due to cranes and the pressure of liquids in containers. So depending on, it's like, this is where we're looking at the use of the building. In industrial buildings, we look at also the additional loads of crane and liquids in containers. Anything stored in the buildings, you're looking at what's the maximum weight of storage to be put in a F3 or an F2 building. The equipments. So this is variable load that's due to the intended use and occupancy that is assumed to be in the design of the structural member of the building. That's the live load. Whereas the dead load is, as indicated above, is the weight of all permanent structural and non-structural components of the building. Load bearing, as applied to a building element, is an element that is subjected to or designed to carry loads in addition to its own dead load, excepting a wall element subjected only to wind and earthquake loads in addition to its dead load. So when we're looking at a wall, exterior wall element, when that is subjected to wind and earthquake loads, we don't say it's a load bearing. It's actually it's resisting to wind and earthquake loads in addition to its own dead load. And in general, load bearing is it's designed to carry loads in addition to its own dead load. So and that's not the loads related to wind or earthquake loads for wall elements. Cavity wall, a construction of masonry units laid with a cavity between the wides. The wides are tied together with metal ties or bonding units and are relied on to act together in resisting lateral loads. So as we see, like wind loads or seismic loads. Braced wall band, an imaginary continuous straight band extending vertically and horizontally through the building or part of the building within which braced wall panels are constructed. Braced wall, a portion of a wood frame wall where bracing, sheathing, cladding, or interior finish is designed and installed to provide the required resistance to lateral loads due to wind or earthquake. Fire block, it's different than blocking, and we showed you this morning what the blocking is used in the different parts of the building. However, fire blocking is used to subdivide a combustible concealed space in order to restrict the spread of fire within that combustible concealed space. So that's related to blocking. Groundwater, freestanding body water. We saw the definitions of this morning for all these elements in terms of affecting foundations and design of foundations. Rim joist is the outermost member in a floor framing other than blocking, be it parallel, perpendicular, or at an angle to the floor joist. So the outermost member in a floor framing other than blocking, be it parallel, perpendicular, or an angle to the floor joist. So this is the outermost member in floor framing. That's the rim joist. Bearing surface is the contact surface between a foundation unit and the soil or rock upon which it bears. Floor area, we are familiar with the floor area, I hope by now. So the space on any story of a building between exterior walls and required firewalls, including the space occupied by interior walls and partitions, but not including exits, vertical service spaces, and their enclosing shafts. We looked at the different definition of foundations earlier today, and we looked at the definition of pile. We looked at the different types of soil components, whether it's soil types, whether it's a rock, whether it's what's the definition of soil. It can be boulders, cobbles, gravel, silt, clay, organic matter. We looked at the fills, soil, rock, rubble, industrial waste such as slag, organic material, a combination of these that is transported or placed on a natural surface of soil, rock, organic terrain. It may or may not be compacted. So 9.41 structural requirement, I think this is a basic summary. We'll go through it quickly. 9411, subject to the application limitation defined elsewhere in Part 9, structural members and their connections. they shall conform to the requirement provided elsewhere in Part 9. That's one. An option, look at the or. You can see the or here. Be designed according to good engineering practice, such as provided in Canadian Wood Council 2014 in Engineering Guide for Wood Frame Construction. So obviously, when you're using CWCW 2014, that's for designing wood frame construction. If you have other types of materials, you still need to refer back to elsewhere to Part 9. Or you can design the building in accordance to Part 4, using the loads and deflection and vibration limits specified either in Part 9 or in Part 4. So the loads and deflection limit and vibration limits for your structural members can be based on those specified in Part 9, and you can do the calculation in accordance to Part 4 if you don't want to use the construction specifications and cookbook recipe for designing walls and foundations and load-bearing components of the buildings. Um, with floor assemblies and roof components. Where floor framing is designed in accordance to clause 1B or C. So whether you're designing to CWC 2014, which is Canadian Wood Council Engineering Guide for Wood Frame Construction, or you're designing to 1B or 1C, and where supporting wall framing and fastenings or footings are designed in accordance to clause 1A, the maximum specified live load on the floor according to table 4153 shall not exceed 2.4 kilopascal. So no matter how you're designing, you cannot exceed a maximum specified live load on the floor according to table 4153 of 2.4 kPa. So these are the limitation on the live loads to be used in Part 9 on structural elements. Location-specific information for structural design, including snow and wind loads and seismic spectral response accelerations, shall be determined according to subsection 113. So these are types of, if you're using location-specific information for those elements, then you have to use those as specified in 113. You need to refer back to them. If you don't have location-specific, you go to the appendix in Appendix C related to climatic and seismic information for building design in Canada. Climatic and seismic values shall be in conformance with the values established by the authority having jurisdiction or in the absence of such data with climatic and seismic values in Appendix C. So this is seismic design data for selected location in Canada. This is table C3 where is table C3? So that's in Appendix C. Where is Appendix C? Under which volume?
Volume 1.
Volume 1. Okay. So if I'm designing in volume 1, what would be the seismic data? And for let's see, this is in British Columbia. You can see the different values for seismic design data in British Columbia. This is an extract, and I'm not going to go through that portion of the design for seismic design, but we know where to pick it up in terms of the calculations specified in under the section for structural design. I would like to take you to 9421 for specified loads. Sorry about that. This is not scientific snow loads, it's specified snow loads here. So what I'll do is I'll make sure to double check some of the slides here and make sure that we'll repost it on the site for you guys. So that should stay specified. Instead of coming here, I will go to 9.4. And this is where we are in 9.4.2. So you'll see when you're in each types of construction, whether we are wood frame construction, we need to see 942 for specifications for types of construction, structural design of typical construction. This is attics and roof spaces. You'll see that the ceiling joists and in residential attic and roof spaces having limited accessibility that precludes the storage of equipment or material shall be designed to a total specified load of not less than 0.35 kPa, where the total specified load is the sum of specified dead load plus the specified live load of the ceiling. So for each type of assembly in part 9, you'll see that we're going to have specified loads, and this is why in 9.4 at the beginning, it says when you're designing, whether you're designing the calculating based on part 4 or part 9, you can use the specified loadings in in part 9. So here. So in 9.4 structural requirements, it's page 9.6. We went through the applications. We looked at the 3 options for design, whether it's part 9, whether the CWC engineering guide for wood frame construction, or be designed to part 4 using the loads in part 9 or part 4. Okay. So specified loads in general. This subsection applies to light frame constructions whose wall, floors, and roof planes are generally comprised of frames and of small repetitive structural members, and where the roof and wall planes are clad, sheathed, or braced on at least one side. The small repetitive structural members are spaced no more than 600 millimeter on center. So whether and the clear span of any structural member does not exceed 12.2 meter. The maximum deflection of the structural roof member conforms to 9431. The maximum total roof area, notwithstanding any separation of adjoining buildings by firewalls, is 4,550 meters squared. For a flat roof, there are no significant obstructions on the roof, such as parapet walls spaced closer than the distance calculated by the formula here, which gives you for flat roofs, there is no significant obstruction, and of parapet walls that are spaced closer than the distance calculated by this formula, which basically it's addressing the snow loads on the roof on flat roofs and what are the distances that the space, what obstructions, the distances between obstructions, what's that minimum distance that needs to be designed for. Notice that the maximum total roof area, notwithstanding any separation of adjoining buildings by firewalls. So if you have adjoining building and separated, so even those separated by firewall, you don't want that maximum total roof area of those buildings altogether to exceed 550 meters squared. The design is small repetitive structural members that are spaced not more than 600 millimeter on center. So if you're having designs that's more than 600 millimeter on center, definitely you're going into part 4. Your roof walls planes are clad. So this is for repetitive structural members, and they can be clad or braced and sheathed on one side at least. And the clear spans of structural members, that's 12.2 meter maximum. Specified snow loads. The specified snow load shall not be less than those calculated using the formula. You can see the formula where S is the specified snow load, CB is the basic snow load roof factor, which is 0.45, where the entire roof width does not exceed 4.3 meters, and 0.55 for all other roofs. The the factors SS is 1 in 50-year ground snow load in kPa, and SR associated 1 in 150 rain load in kPa determined in accordance with subsection 113. So in order to find what is SS and SR, where do we want to go? So in accordance to 1 in 50 rain load in KPA. Page down. Okay. So we saw that. So let's take a look here at this table. So we go to the climatic design data. So 1 in 50. Can you tell me what is the 1 in 50 rain? 1 in 50 rain roads for snow load. What is the SS and SR? The 1 in 50 snow loads SS and SR for Bella Coola in BC.
4.5 and 0.8.
Yeah, so thank you, Dan. Thank you, Dan. So you guys know where to find the SS and SR to go back to the formula. So when you're looking at the formulas, you need to identify the SS and SR. Okay. Any question on that? All right. Down. Specified loads, these are some provisions in 9.4. In 9.423, platforms subject to snow and occupancy loads, balconies, decks, and other accessible exterior platforms intended for an occupancy and subject to snow loads shall be designed to carry the specified roof snow loads or 1.9 kPa, whichever is greater, where the platform or each segregated area of the platform serves a single dwelling. So these are the platform, decks and balconies, exterior platforms where people are going to sit or they're going to be used. You need to make sure that they're going to be designed to carry a specified roof snow load or 1.9 kPa, whichever is greater, where the platform, each segregated area of the platform serves a single dwelling unit. In attics and roof spaces, the ceiling joists or truss bottom cords in residential attic and roof spaces having limited accessibility that precludes storage of equipment or material. So you don't have any storage of equipment shall be designed for a total specified load on not less than 0.35 kPa, where the total specified load is the sum of the specified dead load plus the specified live load of the ceiling. So if we go here into our requirements, we've got specific conditions that we don't use the formulas for them, but we use the lesser of the calculated or the 1.9 for platforms. And for attic and roof spaces where you don't have storage of equipment or material, use the specified load of not less than 0.5 kPa. That's it's only for residential attics and roof spaces. Deflections, the maximum deflection of structural members shall conform to 9431, and the dead loads need not be considered in computing deflections referred to in sentence 1. So you don't add up the deflection needed from the based on the because of the dead load of the element. You're looking at the deflection caused by the live loads, and you've got the maximum allowable deflections as an expressed ratio of the clear span of the element. So you've got maximum deflection for roof rafters, roof joists, roof beams, ceiling joists, floor beams, floor joists, and floor decking, beam joists, and decking for balconies and decks and other accessible exterior platforms. So just to make sure we're familiar with that table. So what's the maximum deflection of joist support floor beams or floor joists? Someone, please.
One over 360.
Thank you very much, Maher. Okay. Foundation conditions 9.44. So allowable bearing pressures we're looking at 944.1 footing sizes for shallow foundation shall be determined in section 915. Designed in accordance with section 4.2. Again, it sends us to section 4.2 using the maximum allowable bearing pressure of 9,441. So similar to structural elements where we're doing design loads, we can use part 4, but when we're using part 4, we can actually use the maximum allowable bearing pressures, maximum allowed design loads from part 9. Or for footings, for shallow foundation, you can use the allowable bearing pressure as determined from subsurface investigation. So if we're looking for the maximum allowable bearing pressure in table 9441, let's see what that tells us. So based on the type of soil, what's maximum allowable bearing pressure for with clay shale?
300.
Perfect, thank you. Okay, the foundation, then we look at 9442, we look at foundation capacity in weaker soil and rock, in high water tables, soil movements, retaining walls, and walls supporting drained earth. Let's see, so this is an example of designing a foundation to a lower bearing capacity. This is in 9442. So what this is showing that the footing width is W, the bearing pressure you're showing where's the bearing pressure on the footing. And if you have some kind of soil that is of lower bearing capacity than the higher bearing capacity, then this you need to design for the lower bearing capacity within the if you have lower bearing capacity soil within twice the width, the footing widths. That's what 9442 telling you, and this is an illustration of that provision in the illustrator's guide. There are provisions specifically related. So if we're not looking at the design of the major structural elements, and we're looking at wood framing, steel frame construction, metal frame construction, where we're looking at foundations, and we look at major construction elements of the building are all specified, and we have the design requirements, the load requirements based on the span tables for joists and floors, and for the roofs, as well for load-bearing walls. What else remains? We've got also elements, smaller elements like guards. They're designed for specific loads, and you need to make sure that the guards are able to withstand those specified loads related to in their sections. So in table 9.88, we look for specified loads for guards, and cantilevered precast concrete steps. Also, they have specific provisions specific to them in terms of design and the loads that they need to be designed for. Let's see. Retaining walls, deflections. Okay. So what are other elements that we need to look out for design and loadings? We're looking at footings at foundations. We're looking at floors on ground. We're looking at columns, masonry, and insulating concrete form walls. We're looking at masonry and concrete chimneys and flutes, how they are designed, wood frame construction. And we've got the span tables addressing wood frame constructions as well as other type of construction. We've got sheet steel, stud walls, framing requirements. So these are all elements related to that would have components related to structural design of those types of structural assemblies. If you want to go over in more in detail related to that, we can go into wood frame construction and take a look at that. So go to section 9.23. Let's see, 9.23. Page now. So for wood frame construction, this section applies to the constructions where wall, floor, and roof planes are generally comprised of lumber frames and small repetitive structural members or engineered components. So it allows you to use engineered components where roof and wall planes are clad, sheathed, or braced at least on one side. Remember, this is wood frame construction. Small repetitive structural members, we've seen that before. The construction do not serve as foundations. So this is not part of the foundations. The specified live load on supported subfloors and floor framing does not exceed 2.4 kPa, and the span of any structural member does not exceed 12.2 meters. Where the condition in sentence 1 are not met, or they are exceeded for wood construction, where do we go to? We go to the design of the framing and fastening to subsection 4.31. So if we exceed the provisions, the limitations of application in section 9.23, or for that matter, in every other section where there's limitation on applications, most of the time we're being sent to other parts of the building codes which are applicable to all buildings. 923.1, it talks about general provisions related to strength and rigidity. So these are performance requirements, protection from decay, ends of wood joist, beams, and other members framing into masonry or concrete shall be treated to prevent decay where the bottom of the member is or at below ground level, or a 12 millimeter airspace shall be provided at the end and sides of the member. So this is you're trying to protect your wood from rotting. Airspaces required in sentence 1 shall not be blocked by insulation, vapor barriers, or airtight materials. So you want air circulation in this area to make sure your wood members dry. Protection from dampness, exception as permitted by sentence 2. Wood framing members that are not pressure treated with a wood preservative that are supported on concrete and in contact with the ground or fill shall be separated from the concrete or the fill by not less than 0.005 millimeter polyethylene film or type S roll roofing. So this is related to dampness and damp areas of the building, and you want to protect the wood framing members from that. Damp proofing materials referred in sentence 1 is not required where the wood member is at least 150 millimeter above ground. If you have it 150 millimeter or more above ground, you don't need damp proofing material on your wood member. And lumber shall be conforming to subsection 932, which we saw earlier. 932 specifies the standards that each types of that lumber and wood wood construction elements need to meet in terms of specification standards that they have to meet. Goes on to tell us about the fasteners that are used with wood frame construction. Diameter of nails, length of nails, prevention of splitting, nails of the framing, and minimum and maximum spacing between nails for framing, fastener for sheathing or subflooring, And for each type of wood member, you use different types of nails, ring thread of nails, and roofing nails and staples. You have the options and minimum number of maximum spacing of fasteners. And this one is for sheathing, where you have different pressures, wind pressures related to sheathings. Maximum spans. This is for joist, beams, and lintel supporting floors. It tells you that spans provided in this subsection for joist, beams, and lintel supporting floors shall apply only where the floors serve residential areas as described in Table 4153. The uniformly distributed live load on the floors does not exceed that specified for residential areas in Table 4153. Span for joist, beams, and lintel supporting floors shall be determined to subsection 4.13, where the supported floors serve other than residential areas or support a uniform live load that is in excess than that's specified for residential areas. And then spans for joist, rafter, and beams, except as required in sentence 2 and Article 923.14.10, spans for wood joist and rafters shall conform to the spans shown in span tables 923.42a to 923.42g for the uniform live load shown in the tables. And we know now where to find those span tables. Those span tables are available where? Where are the span tables related to Part 9?
Volume 2.
Volume
Page
2, it's yeah, so it's after.
447.
Yeah, so this is after the fire and sound resistance tables, we find the span tables. Okay. Spans for floor joists that are not selected from span tables 923.42a and 923.42b and that are required to be designed for the same loading conditions shall not exceed the design requirement for uniform loading and vibration criteria. And spans for built-up wood and glued laminated timber floor beams shall conform to the spans in tables 923.42h to 923.42k. And for ridge beams, you have to use span tables 923.42l for uniform snow loads. So it tells you exactly what spans you have for the different types of elements where they are used in the construction of wood frame construction. If you have steel beams, the spans for steel floor beams with laterally supported top flanges shall conform to table 923.43. And beams described in sentence 1 shall meet at least the requirement for grade 350W steel contained in CSA G4021 structural quality steel. So these are the maximum spans for steel beams supporting floors in dwelling units. This is wide flange beams, W200 by 21. And these are supported joist lengths that are supported by the wide flange beams in dwelling units. What's the concrete topping? Where a floor is required to support a concrete topping, the joist spans shown in table 9.2342a or the spacing will be reduced to allow for the loads due to the topping. So now it's also the topping adds to the load on the member. So you need to address the joist. Basically, you need to make sure that the spacing of the members to be reduced so that you can account for the structural loads. Or or except in sentence 2, where the floor is required to support a concrete topping, joist spans are permitted to be selected from table 9.2342b, provided the concrete is 38 to 51 millimeter thick. It is normal weight, is placed directly on the subflooring, and it has a strength compressive strength not less than 20 megapascal after 28 days. Where the floor is required to support a concrete topping not more than 51 millimeter thick, the allowable beam spans in table 923.42H2K shall be multiplied by 0.8, or the supported length of the floor joist shall be reduced to allow the loads due to the topping. So you increase the load or you multiply by 0.8. the spans for the allowed spans. Heavy roofing materials. This addresses 92345 when a roof is required to support an additional uniform dead load from roofing materials such as concrete, roofing tiles, materials other than as specified in 9.27, such as clay roofing tiles. The additional load shall be allowed for by reducing the floor spans of roof joists and rafters in span tables 923 for 2D and 2G, or the spacing of the members needs to be reduced. The spans for ridge beams and lintel spans 9.23 for 2L and 9.2312 3A to 92323D. It goes on to notching and drilling. I'm not going to go read that. It talks about the anchorage and anchor bolt spacings, anchorage of columns and posts, anchorage of smaller buildings, sill plates, beams to support floors. It's floor joists and bearing for joists, joists supported by beams, restraints of joist bottoms, strapping, bridging, and furrings and ceilings. Other joists, trimmer joists, support of walls, cantilevered floor joists, wall studs, size and spacing of studs. So if I have an interior wall, what's the minimum stud size if it's not if it doesn't support it's not load bearing. There is no load on it. So minimum stud size is what? No load. This is for walls in wood frame construction. Can you see table 923-10-1? If I don't have any load, the minimum stud size is what?
38 by 38?
Thank you, Dan. And maximum stud spacing is
400.
400, and the maximum unsupported height is 3.6. If it's 3.6, as you can see, that 3.6 is the typical maximum height. The only exception I can see is for attics, I can get up to a 4.2 and 4.2. Otherwise, in other areas, it's pretty much 3.6, the maximum unsupported heights.
Can I just ask a question about that minimum load, or sorry, stud size? 38 by 38 is a 2 by 2.
Yeah.
I've never seen such a wall. I mean, that's basically used for
That's a
strapping.
no load, basically. It just says there's no load on this. Yeah, a typical, I mean, you can go smaller in attic. You can see down to 38 by 60. Well, no, I mean, you see the 38 by 64, 38 by 89 typically. The 38 by 89 is typically, and 38 by 140 you will see. But when you're doing partitions, no, you can go down to 38 by 38. I'm not sure how old this table is, but pretty much it could have been, those sizes have been in there for a long time.
Can I also ask a question about this table?
Yes.
The underneath no load, there's also attics,
Yes.
attics plus floor. What if you don't have an attic? What if you just have floors? Oh, never mind. I see. This is roof load plus floors. Okay. Never mind. Thank you.
Yeah. And then you can see, always remember that there are different notes to the table. So you go to the notes in notes A94211, and it sends you to see the article in 38 times 89 flat. It sends you to article C92310.3, which is related to orientation of the studs. So except as permitted in sentence 2 and 3, all studs shall be placed at right angle to the wall face, which is typical. Studs on a flat are permitted to be used in gable ends of roofs that contain only unfinished space or in non-load bearing walls within the limits described in Article 923.10.1. So As you can see here, we have very limited wall heights, but for gable walls, you can see that the orientation, gable ends of roofs, that you can see that where the application of those types of walls may be and studs may be used. Walls that support only a load from an attic roof, an attic not accessible by a stairway, are permitted to be placed on a flat within the limits permitted by Article 9.10.1, provided the studs are clad on not less than one side with plywood, OSB, or wafer board sheathing, fastened to the face of the stud with a structural adhesive, and the portion of the roof supported by the stud does not exceed 2.1 meter in width. So there's limitations. Continuity of studs. Wall stud shall be continuous for the full story height except at openings and shall not be spliced except by finger joining with a structural adhesive. And support for cladding, sheathing, and finishing material. Studs at sides of opening, wall plates, joints and tub plates. Framing over openings, this is critical. The framing over opening, it goes into lintels, spans, and sizes. So here, if we go for in load-bearing walls, you got to be very careful when you're creating openings. So openings in load-bearing walls greater than the required stud spacing shall be framed with lintels designed to carry superimposed loads to adjacent studs. Where two or more members are used in lintels, they shall be fastened together with not less than 82 millimeter nails with in a double row with nails not more than 450 millimeter apart in each row. Only exception to that is lintel members are permitted to be separated by filler pieces. Lintel spans and sizes. Spans and sizes of wood lintels shall conform to the spans shown in span tables 923.42L and 923.12.3A to 3D. For building of residential occupancy, where the stud walls exceed 38 by 64 millimeter in size, and where the spans of supported joists do not exceed 4.9 meter, and where the spans of trusses do not exceed 9.8 meter. So you can use the tables if you are under those conditions. So in load-bearing exterior and interior walls of 38 by 64 millimeters, framing member lintels shall consist of 64 millimeter thick members on edge, or 38 millimeter thick and 19 millimeter thick members fastened together with a double row of nails shall not be less than 63 millimeter long and spaced not more than 450 millimeter apart. Lintels in sentence 2 shall not be less than 50 millimeter greater in depth than those shown in span tables L to A and A to D for the maximum spans shown, and shall not exceed 2.24 meter in length. So these are lintels for created to support walls, load-bearing walls when we have openings in them, and how to design those lintels to support the additional loads. Bracing to resist lateral load due to wind and earthquake. So these are requirements related to those elements. And we know where to find those SS and SA factors for each region. And we've got bracing for walls, wall bands, and maximum. So these are the spacing and dimension of brace wall bands and brace wall panels, depending on SA and SA values. So these are for. And the materials in braced wall panels, what are the materials that needs to be used depending on SA values. Additional system considerations, you got to make sure that you meet all these provisions when you're dealing with seismic and wind framing. Roof and ceiling framing. These are, again, similar to walls. This is roof and ceiling framings. We've got different specifications for the different elements of the roof. And then we get to subflooring. We get the materials where the requirements related to that, and then specification of how to install, thicknesses, limitations in in spacing, in nails, in attachments, designs of connections, lumbar subflooring. Lumbar subflooring shall be laid at an angle of not less than 45 degrees to the joist. So lumbar subflooring shall be fully supported at the ends on solid bearing, and lumbar for subflooring shall be uniform thickness of not more than 184 millimeter wide. So that's if you're using lumbar subflooring. And we go on to roof sheathing, material standards. Again, we have required sheathing in terms of performance, when it is required, and how to install it, what thicknesses to use and limitations. Now we've got wall sheathing. I'm going quickly through that because we're not going to do the design of the building. We're just identifying critical elements of wood frame constructions, and we have gone, and this completes the wood frame construction. So all the components of wood frame construction, if you're designing for seismic design, snow loads, you've got provisions related to that, whether you're in wall, whether in roof framing, wall framing, or load bearing or non-load bearing, or you're designing for floors. There's different elements related to those, and for specifically for structural lumbar elements, structural elements, there's specific requirement for that. Section 924 is the sheet steel wood stud wall framing. Again, similar to the wood framing, it's got specification for minimum stud sizes, spacing, and wall heights, thicknesses. And thickness and runners. Let's see, you've got runners for interior and exterior non-load bearing walls, and openings and fire separation in them, and side and spacing of studs in exterior walls, installation of runners, and when you have fire rated walls, orientation of studs, supportive cladding materials, opening for fire dampers. So 924, there's specific requirements that when you have different performance level for the wall, what you need to address in terms of provisions. And that's all under sheet steel stud wall framing. So you got to be careful with when you're creating openings and fire separations in sheet steel wall framings, there's specific provisions related to that. And opening for fire dampers in the walls, you need to address the provisions related to the installation of such dampers. There's a sill and a header, the opening, and then the use of gypsum board. So I think with that, I'm not going to cover any more of structural unless you guys have any specific questions related to structural. But you know where to go to in terms of the requirements for different types of assemblies, different types of materials. You know how to go back to the climatic and seismic information, climatic information specific to snow loads, seismic informations where you're designing for seismic resistance, and so any questions on structural? We're going to move on to the, yes, Alberto.
Sorry, this is a quick question. In page 97, where the formula of a specified snow load. So we have to.
What is that? 97?
9422.
942?
Yeah, 9422. So it's where we have this formula.
Yeah.
So we have two values, SS and SR. S is snow load and SR is rain load. So in the chart, in the climatic design,
yeah.
So then we have SS and SR under snow load. So one is for rain and the other one is snow, and both are under snow load.
No, you gotta go to the definition. So okay, SR, it's associated, it's 1 in 50 rain load in kPa, and okay, that's the SR, and a 1 in 50 ground snow load in KPA determined in accordance to subsection 113. So the 1 in 50 ground snow load in KPA and the SS and SR that are provided for you under the tables in climatic, right? But the heading is a little bit it's a little bit misleading because it's telling you the 1 in 50 snow load, but it's actually also 1 in 50 year rain. So they did not put it in there. So they just put the one for snow load.
Yeah.
Okay.
Makes sense.
Always go back. Yeah, always go back to the to the formula, because right after the formula you see the definitions of the terms of the formula, and actually if you want to understand what are the different meaning of all these elements in the equations and in those tables, in the beginning of Appendix C, there is all the discussion of all the different terminology related to those terms and how they are determined. So that's it's the essential reading for using the tables.
Okay.
Okay.
Yeah, thank you.
You're welcome. All right. So now we're ready to move into energy efficiency, everybody's favorite subject. And we've made the buildings very tight. Oh, Mark, you have a question.
Yeah, I would just like to follow up the question that Alberto did. I hope it's not that silly, but calculating the specified snow load, only the SS will be multiplied with the CB. Is that correct? And then you add the rain load.
Yes, exactly.
Okay.
Yeah.
Okay. Yeah, I just got a sample calculation which did another way, so I just want to make sure.
No, it's the CB only multiplies SS and not SR. So
Right.
if it multiplies, typically when it multiplies both, you are going to have to put it between parentheses, the SS and SR. You don't have a parenthesis, it's only the first factor.
Yeah, that sounds clear. Question with the deflections. So when you use the span tables for, let's say, roof rafters, roof joists, do I need to have a separate calculation for deflections, or was it already considered on the tables?
No, that's already considered on the tables in terms of the spans. Now, unless you have some other conditions that you need to consider live loads for calculating for other provisions, then you need to do that calculations. But typically, the tables are addressing the maximum spans for the typical maximum loads in the building. So
Yeah, that's clear now. Thank you so much.
And be remembered, when you're using the span tables, there are specific span tables for specific conditions. So do not go use them without reading where to use them. Let's see. Page up. Did we go? Okay. Any other question? Alberto, you had a question or your hand is still raised?
I have a very quick question, and it's regarding to the concrete topping.
Yes.
So it says that we have to reduce to allow for the loads, but it doesn't say in the quantity or how much. So it's just like a some rule, or
there is a note related to that. So I would recommend you go to the note and read what the note says related to it.
Okay, thank you.
Yeah. So for energy efficient design, what makes a home energy efficient? This is from NRCan. It's a drawing. So we're looking at, we've already come across some of these elements related to airtight construction, So air barriers, air ceilings, vapor barriers, let's see, lighting, electrical components, windows, doors, better installations. We looked also at heating appliances generating energy. So appliance using energy also, these are related to, we can also look at, they all contribute to the home energy efficiencies. So in those, we just go back and double review the terminology of air barrier system. It's resistance for the movement of air. The vapor barrier, resistant to the control the diffusion of water vapor. And what's a conditioned space? Is a space within the building with the temperature in which is controlled to limiting variations to the exterior temperature by the provision of either directly or indirectly heating and cooling over substantial portions of the year. So energy efficiency compliance options for part 9. This one is from the notes. Okay, this is part of the code and it's related to the notes. It summarizes for us where is the energy efficiency compliance is required according to part 9 buildings. So we can read the application. We will go through that, but this summarizes it for us. 936.1.3, it relates to provisions to 936.1.13. So in building types and sizes, houses with or without secondary units, we go to the prescriptive provisions related to the elements we discussed in terms of insulation, air barriers, vapor barriers, equipment. We go to 936.2 to 936.4. Or we can use 936.5 performance-based approach calculations, or we can use the National Energy Conservation Code. We can also use, then we also have buildings containing only dwelling units with common space, less than 20% of the total of buildings' total floor area. So if we have dwelling units with the common spaces less or equal than 20% of the building total floor area, this is where when you're talking about building total floor area, it's different than the building floor area. So building total floor area, you add up all the floor areas. We can also use the provisions related to NBC 9365 and the National Energy Conservation Code. For Group C occupancies, for buildings containing Group D, E, F3 occupancies less than 300 meters squares combined total floor area, and building with a mix of Group C, D, E, or F3 occupancies where the non-residential portions or portions combined total floor area is less or equal than 300 meters squared. So in this case, we use the provisions of 936.2 to 936.4 or the National Energy Conservation Code. And for building containing Group DEF3, whose total combined floor area is greater than 300 meters squared, the National Energy Code, Energy Conservation Code, and building containing F2 occupancy of any size, also you need to go to the National Energy Conservation Code. So the NECB can be used for all buildings, but it's a must be used for Group EDF3 that are more than 300 meters squared, or buildings that contain an F2. For Group C occupancies other than houses with secondary suites, and buildings in which the common dwelling units that have common spaces less than 20% of total floor area, you can use 936.2 to 936.4, NBC 936.5. 936.2 to 936.4. The 936.5 performance-based approach is only for the houses with or without secondary suites, or buildings with dwelling units with less than 20%, less or equal 20% common space areas of the total floor area. So this table summarizes for us what this is intended to be done, what this tells us to do. You can see where all the references are for 936R. 936. So this section is concerned with the energy used by buildings as a result of the design and construction of the building envelope and the design and construction and specification of systems and equipment used for heating, ventilating, and air conditioning, and surface water heating. You've got certain definitions here under the sections for thermal common space, for overall thermal transmittance, for effective thermal resistance, RSI, and what the term fenestration means. We're going to go back to them. However, the compliance and application, this is what the table summarizes, 9613. So the table we just looked at summarizes the provisions of 9613. So you can use the guide table, or you can go back and read this to make sure whether this the provision of 9.6 energy efficiency requirements apply to you, to your building or not. Okay, so if the National Energy Conservation Code is not adopted, then you don't have any provisions related to Group D, E, and F3 of greater than 300 meters squared, and buildings containing F2 occupancies of any size, then you don't have any provisions. You need to make sure that the National Energy Conservation Code is applied in your province to make sure it's to apply it. But based on references from the National Building Code, that the National Energy Conservation Code is referenced, so you would be using it. So if we go 931, 932, 933, we see related to equipment, section 931 section applies to the plumbing facilities and plumbing system used within dwelling units. Systems used for surface water heating shall conform to the energy efficiency requirements in section 9.36. In 932, we're looking at ventilation of room and spaces in residential occupancy, and how it sends us to 936, ventilations of other occupancies in conformance to part 6. So you use 9.32 only for residential occupancies. For other occupancies, you go to part 6. And systems used for ventilation shall conform to the energy efficiency requirements of section 9.36. 933 section applies to the design and installation of heating systems, radiant heating systems. So when they're serving only one dwelling units or houses with a secondary suite, including their common spaces. For all other occupancies, the systems for heating systems designs and air conditioning systems need to conform to part 4. The heating and air conditioning shall conform to energy efficiency requirement of 936. And air duct distribution systems in which the rated heat input exceeds 120 kilowatt shall conform to part 6 and subsection 3.65. So when you're reading your equipment sections 931, 932, 933, make sure to read the application sections, the limitation sections, and where they send you to what parts of the building code, to which equipment applies the provisions, the energy efficiency requirements. Climatic and seismic data based on, we know how to read this. So we know that they are to be in conformance with the values established by the local authority. And then if that's 113 tells you need to use those local values as published by your local authority. If not, in the absence of such values, you can go to the climatic and seismic tables and in part 9 related to those designs in Appendix 6, but not in part 9, Appendix 6 of the building code. So that's Appendix 6 is in Volume 1. The outside winter design temperature determined in Appendix C shall be those listed for the January 2.5% values. So again, this is the outside winter design temperatures. That's what you would take. The depths of the frost penetration shall be established on the basis of local experience. So you have to look for local experience to be designing for frost penetrations. General 936.1. I think it's easier to go to the code and read it. Before we do that, let's take a look at definitions. So this is another area of the building code. We've seen it before in terms of definitions. We're looking at the definition here of common space shall mean all spaces required to be conditioned spaces in accordance with the requirements of the code that are not within a suite, but shall not include crawl spaces and vertical service spaces. So common spaces that need to be conditions, but are not crawl spaces or vertical service spaces and are not located within suite. The overall thermal transmittance or U value shall mean the rate in watts per meter squared Kelvin at which the heat is transferred through a building assembly that is subject to temperature differences. So we have a U value every time we have temperature difference, and it's measured in energy values per meter squared by Kelvin temperatures. For the purposes of this section, the term effective thermal resistance. So we have an overall thermal resistance for materials, and then within the assembly, and then effective thermal resistance for the assembly, or RSI value, shall mean the inverse of the overall thermal transmittal of the assembly in meter squared Kelvin per W. So overall thermal transmittance and effective thermal transmittance. So one is the RSI is the inverse of the overall thermal transmittance, and we're gonna look at the overall thermal transmittance in terms of the overall assembly thermal transmittance versus the individual thermal transmittance of the materials used within the assembly. Effective thermal resistance, then we have the RSI value is the inverse of U. For the purpose of this section, the term fenestration shall mean all building envelope assemblies, including their frames that transfer visible light, such as windows. Clerestories. I have not looked up what clerestories is. If one of you can guess what it means, please share it with us. But if none of us knows what it means, then we can look it up in the dictionary. Visible, such as windows, clerestories, skylights, translucent wall panels, glass block assemblies, transoms, side lights, sliding overhead or swinging glass doors, and glazed inserts in doors. So maybe if we look up 936.124, we can figure out what clerestories is. Anybody, any volunteer to get us that definition of clerestories?
Yes, clerestory is the windows below the roof, like higher windows.
Oh, okay. Well, thank you for that.
You're welcome.
Yeah. So we've looked at definitions. We looked at compliance and applications. Scope and applications. So we've, okay. This section, the building envelope. So we look at the building envelopes. We look at 936.2. Let's look, this is just general sections. So building envelope. And then after building envelope, we have (36.3) HVAC requirements. 936.3. And after HVAC requirement, we have service water heating systems. And then the energy performance compliance can be used under one condition, and this is for houses. Let's see, look based on the application provisions. So when we're looking at design for energy efficiency, we're looking at 936, 4, 3, and 2 for envelope elements. So the equipment and the envelope. So when you're looking at the envelope, building envelope, this subsection is concerned with the loss of energy due to heat transfer and air leakage through materials, components, and assemblies, including their interfaces, forming part of the building envelope where it separates conditioned space from unconditioned space, the exterior air, or the ground. Okay? They also apply to components of a building envelope assembly that separate a conditioned space from an adjoining storage garage, even if the storage garage is intended to be heated. For wall assemblies inclined less than, for the purposes of this section, wall assemblies inclined less than 60 degrees from the horizontal shall be considered as roof assemblies, and roof assemblies inclined 60 degrees or more from the horizontal shall be considered as wall assemblies. So each they have different performance requirements. Ah, somebody shared a picture with us. Is that the picture we were looking, Hamid, for the, what is that, clearer stories? Is that what it is?
Yeah, that's the one.
Oh, thank you. See, you're all architects. You can tell me a lot of nice things, nice pictures. Nijar, thank you. You had a question?
Actually, my question is not relating to this section, so I can actually ask it at the end of the session.
Perfect. Thank you. Sorry we
Thank
missed
you.
that.
No, I just lowered my hand, so it's not going to confuse it.
Oh, okay. Great. Thanks. Let's remember it. Yeah. All right.
Sure.
So we have for what the walls, how when we consider it part of the wall, when we consider it part of the roof. So when we have inclined walls, then we need to make sure that if they are at 60 or more, they're part of the roof at 6. And if we've got roof assemblies inclined 60 or more from the horizontal shall be consolidated wall assemblies, and wall assemblies inclined less than 60 from the horizontal, they need to be considered part of the roof assemblies. So this is reminding us that we also need to conform to the provisions of 9.7, and it also reminding us that we need to go to 9.25 for air barriers, thermal insulation, and vapor barriers and materials with low air and vapor barriers shall also conform to section 9.25, where we're looking at heat transfer, basically performance of building materials. The thermal characteristic of materials and components, this is specifying to us how to, what are the standards related to those products, the tests, how the test and the calculation need to be performed, at what temperatures, the thermal characteristics that for window doors, they can be done by calculation or testing. Effective thermal resistance of opaque building assemblies shall be determined by calculations conforming to 93624 or laboratory tests. For log walls, how it can be determined, and then calculation of ceiling wall fenestration or door areas for your calculation, and a calculation of effective thermal resistance, continuity of insulation, and thermal characteristics of above ground opaque building assemblies. These are all elements of your envelope, ending on the zones. And if you're looking at the climatic data in Appendix 6, you can see the zone. Degrees days between below 18 degrees C's, and depending on and it gives you values between less than 3,000 to over 7,000, and that's the climatic data tables that will provide you in which zone you will fall. Effective. So depending on with or without a heat recovery ventilator, you will have different effective thermal resistance to use in the equation. And then this one is fenestration doors and skylights. Overall thermal transmittance of skylights. Compliance option for site-built windows and glazed portion of doors, depending on the climate zones, and different prescribed values that you can take from this section. And then you go to thermal characteristics, building assemblies below grade or in contact with the ground. It refers you back to applicable heating dates in day category 3628A, where the ventilation system does not include heat recovery equipment, or 93628B, where the ventilation system includes heat recovery equipment conforming to Article 936(9). So again, this is depending on the zones, and for specific applications, junctions, you've got the perimeters outside of foundation walls provisions. Air tightness, this is for air barriers. You got specific provisions, the details of the construction of the air barriers for the joints, locations, interfaces, depending on the type of constructions you're dealing, whether with chimneys, steel line chimneys or masonry concrete chimneys, party walls, air tightness. Finally, you've got trade-off options for above ground building envelope components and assemblies. And then you go into the HVAC requirements and the heating. You've got equipment ducts, air intakes, outlet dampers, piping, temperature controls. You gotta, you follow the specification and the calculations in terms of what are the specification related to HVAC equipment efficiencies and the capacity of each one of them, what specifications we have for the unit heaters, solar systems, and then we have heating systems. Again, the equipment efficiencies and depending on the type of equipment that is used. So these are tables. You need to familiarize yourself with them. The definition of the term, definite terminology is below the table. Within the text, you need to make sure to review it, and any specification related to components of those systems, make sure to address it, to read the requirements for the components of those systems and what are the limitations in terms of installations. Another options which is allowed for houses is energy performance compliance. So this relates to modeling the energy performance of component systems and assembly, including heat gains from internal loads that are installed in building described in 936.133. So and we have seen the modeling provisions. It's pretty limited in terms of application in the building code for residential buildings, some types of residential buildings. So the internal loads that to be addressed, including those that we are typically addressing in terms of thermal analysis, you include the lighting of unconditioned spaces, exterior lighting, and ventilation of conditioned spaces. This section also has definitions. You've got the reference house, you've got annual energy consumption, house energy target, and principal ventilation rate. And there is a whole science around using modeling for houses and calculating performance using modeling for calculating the performance compliance calculations for the annual energy consumption of the proposed house and how it compares to energy target, the house energy target of a reference house. HVAC system calculate again. If you're doing it for the different systems for different components, and you're looking at the total energy as it compares to the referenced house. I'm not going to go into the details of that. That's a topic on its own. So this in the presentation, I outlined for you the components and the subsections and the articles related to the calculations in 936.2. And we've seen some of the specification of thermal resist. We've got in the notes. Something useful for us to use is thermal resistance values of common building materials. So that's from the notes in part 9 at the end of part 9. This is installations. This is illustrations of how you use you install installations on foundations. So it relates to 936, where the installation is to be used depending on the depth of the foundations and the footings. Energy efficiency 936.3 and 936.4 relates to the equipment. And the fire energy performance calculations, if these are calculations related to houses or modeling, using modeling. And in terms of specifications, drawing and calculation for energy performance compliance, subsection 228 applications. So I'm looking, this subsection applies only to houses with or without a secondary suite, into buildings containing only dwelling units and common spaces whose total floor area does not exceed 20% of the total floor area of the building, that are modeled in accordance with subsection 936.5 of Division B to demonstrate compliance with the energy efficiency objective of subsection 936.2 to 936.4 of Division B. Sentence 936.1.2 of Division B, and you've got the notes. So these are the notes that are relevant to that. Where are those provisions?
Where's 228?
Yeah, exactly. That's my questions. Where is 228? I'm now, when we're looking at drawing specifications and calculations, if I'm going to use a specific word, you're going to know exactly what it is. Let's see, what are the documentation and reports related to building design? Where do we go to know where are those what are the requirements related to those documentations related to building construction and design? Where do we go through that? Information required on drawing and specifications. What do we put in? When do we need calculation reports to be submitted? Okay, let me ask you, which division of the code addresses those provisions?
Is Division C?
Excellent. Yes, Alberto. Yes, in Division C. Where in Division C?
Volume 1.
In Volume 1. Division C is in Volume 1.
Administrative provision, part 2.
Yes, administrative provisions, part 2. So let's go to 2. Is that 2.28? There we are. Now in National Building Code, you gotta be, we have the provisions in Division C, which are generic requirements of submissions. But of course, in your local jurisdiction, they will have specific provisions related to what information you need on drawings, what drawings to submit, what specification you need to submit, and what calculations you need to submit, and what information to use for submissions. However, in the National Building Code, they're telling us the minimum submission requirements that would be required for energy compliance, performance compliance in 228, And because we're doing performance design, it applies only to houses with or without secondary suites and to buildings containing only dwelling units in which the common spaces whose total floor area does not exceed 20% of the total floor area. Now, this is for the energy performance compliance, right? Not for energy, you know, when we are using energy, these are modeled in accordance with 936.5 to demonstrate compliance. The ones that are designed for in the previous subsections, they're part of building design and they meet the energy efficiency specification because they're constructed in accordance with the provisions of the code. But if you opt for doing modeling for the house, this is the minimum specification for energy performance compliance, and that's why this subsection applies only to the houses with or without secondary units. What are the information required on drawing and specifications? You've got effective thermal resistance values and respective areas of all opaque building envelope, overall thermal transmittance, ratio of total vertical fenestration and door areas to gross wall areas, performance rating, energy source, type of equipment required for space heating, cooling, and surface water heating, design basis for ventilation rates. If you have done a test for air tightness, to measure air tightness of the building envelope, any additional features in the energy model calculation that account for a significant difference in the house energy. So if you don't want to use the prescriptive provisions of 9.36 and you opt for the performance provisions for houses, for the design of energy efficiency, then there are specific requirements that you need to submit. And the report itself needs to be provided. You need to have it has to include the name of the identifier of the project, description of the project, the address of the project, the name and version of the calculation tool that was used, the geographic region in which the house is proposed to be built, and the identifier for the climatic data set that is used for the analysis, as well as summary of the characteristic of the building envelope, HVAC system, and surface water heating system reflecting the provision in 2282. So, and it goes on to energy performance data summary, and where a software program is used to determine compliance, the name of the software programs, the list of any adaptation made by the user to the software relating to input and output values, and a statement that the calculation was performed in compliance with 936.5. So that's for energy efficiency compliance. Functional statements, alternative solution, division A, part 1, 2, 3, that we've done some of that this morning. We can do some of them right now, but I want to lead you to take a look at section 2.3. Section 2.3 is alternative solutions. So if you want to do alternative solutions, you are permitted to provide alternative solutions by the building code. And this is the documentation required in the NBC. Cautionary remark that local jurisdictions will have different or additional provisions for documentation of and submission of alternative solutions. So, but in general, you want to make sure that you document the equivalent performance in terms of achieving the intended functional statements and objectives of the code associated with the prescriptive requirement for which you are seeking an alternative solution approval. If there are any special maintenance or operational requirements that are critical to your alternative solution, if there is any testing and commissioning requirements specific to some of the installation that you are proposing as alternative solutions, you need to make sure these are included in your submissions. You need to identify any studies, any engineering studies, any assumptions, any restricting factors, limitations that you have used, or any testing procedures if you have used them or in your analysis. Same thing with computational methods. You need to identify which ones you have used. The code analysis shall include information about the qualification and experience and the background of the person or persons taking responsibility for the design. So, so the person who is preparing the alternative solution and taking responsibility for the design may be two different people, but they both need to document their qualification experience in the background. The information provided shall be in sufficient detail to convey the design intent and to support the validity and accuracy and relevance and precision of the code analysis. Where the design of the building includes proposed alternative solutions that involve more than one person taking responsibility for different aspects of the design, the applicant for the building shall identify a single person to coordinate the preparation of the design, code analysis, and documentation referred in the subsection. See? Is that it? I think that's it. If in terms of requirements. The notes of part 2, again, you have information required on drawings and specifications for structural design. What, you know, you are familiar with all submission requirements. I'm not gonna go over that. In terms of alternative functional statement and objectives, we've seen some of them this morning. Instead of going to those, I would like you to get questions from you that in terms of we have not addressed earlier on. Any question? Hi, Nijar.
Hi. Okay, so my question is regarding the item 9.7.
Hmm?
Oh, let me just bring it out. Just lost the page. It's about the steel members and the ceiling and floors, and there was a table talking about those ceiling and floor requirements. I'm just wondering, when we're talking about those floor and ceilings in this section, that means they can be either steel or wood members, right?
Yes, in that specific section. Yeah.
Okay. All right. Thank you.
That's in 9.7. Let's see. Let's make sure that we're looking at the same thing.
No, sorry, it's actually 9.10.
Okay.
It's in the fire separations.
That was for steel.
Oh,
That
that's
was
only for
steel.
steel.
That's steel, right? Yeah. It's. Let's take a look. And where did it go?
Okay, so it's 9, 10, 7. It's steel members.
Yeah, 9, 10, 7. If you look at 9, 10, 7, it starts as 9, 10, 7 is it's relevant to steel members. Because you've got more, I mean, what you worry with the steel is heat conduction through the steel. So it's very critical that when you're designing for openings, you don't have thermal conduction due to heat, fire through those openings. So there's specific requirements of how to design for those openings, especially in the fire separations. And that's why it is under, it's pertinent to steel construction.
Yeah, but the item after that, which talks about the fire resistance and combustibility in relation to occupancy, height, and supported elements, there's a table after that which talks about the fire resistant ratings for structural members and assemblies. I just want to know, when we're talking about floor or ceiling assemblies here, is it like talking about only wood construction, or is it steel construction included?
So in 9.10,
yeah, 9.10.8.
oh no, the 9.10.8, it's fire resistance and combustibility in relation to occupancy and height and supported elements. So this is all types of construction. So you can use both combustible and non-combustible construction.
Okay.
Yeah. Sorry, I was looking at when we were looking at the design of construction, wood frame construction versus metal stud walls. And what are the, you know, how you do, and there's openings related to how to address the openings. the construction around the openings in those metal framing walls, and we've seen that already today. But the provisions of 9.107 is specific to steel members. 9.108 is fire resistance for all types of construction.
Okay, thank you.
Yeah. Any other question? Nijar? Nijar, your hand is still up?
No,
Okay.
sorry, that was my question. I just lowered my hand. Sorry.
So you guys followed on that. So 9.7 is talking about steel members. So if structural steel members used for construction required to have fire resistance rating, they need to be protected to provide the required fire resistance rating. But 9.108 talks about the fire resistance rating of structural elements, floors, in assemblies, basically floors and mezzanines and roofs, and that applies to any type of construction, whether combustible or non-combustible construction.
Okay, got it. Thank you.
Yeah. Okay, so no other questions? Anyway, we can go through attribution table. I'm just gonna give you an article, and you tell me what attribution, what are the functional objectives and statements, functional statements and objectives associated with it. So for 936.2.1, can you give me those? 936.2.1.
Sorry, what's the question, Amal?
What are the functional statements and objectives associated with 936.2.1?
It's about the scope and application of the building envelope.
Yeah.
Is that what you are looking for?
Yeah. So I'm looking for the objectives and the functional statements.
So there's none for 9.36.2.1, but there is one for 9.36.2.2.
Yes. So basically because the application statement is telling us where to go and what it applies to, we need to go to, it doesn't have any prescriptive, any associated functional statement or objective in terms of what it's achieving. But the following articles in this subsection, they have specific performance requirements, functions, and prescriptive elements related to what those components must achieve. And that's why, for example, in 938.2.2, you will see some associated functional statements and objectives. So what's the functional statement 92 and objective statements OE11? So we have to go to volume.
So OE1.
Volume 1, yeah.
Is volume 1, division A, page 26.
Okay, good. And what are the definition of these F92 and OE11?
Excessive use of energy is OE11.
Yeah. Somebody else? Who can give me F92?
To limit the amount of uncontrolled thermal transfer through the building envelope.
Excellent. Okay, F92. Okay. All right. So I think most of you are now familiar with that. I hope nobody has any more question on where to find objectives and functional statements associated with prescriptive requirements, where to look up the definitions of these. In terms of alternative solutions, we know where to go to in terms of requirements, and we know that these are allowed because of Division A, Part A, in terms of compliance. We have those. We know what systems require energy efficiency calculations and performance. We have, sorry, let me go back to the presentation. Presentation went away. Okay.
Amal, I'm sorry for missing that, but can I ask, where did you find the F92 again? Just for
Okay, yeah, sure. So if you were in a functional statements in volume 1,
okay,
so you've signed it. That's in part 3, functional statements. And division A of part 1. Part 3, division A.
okay,
Sorry about that. I said part 1, but it's part 3, division A.
okay.
And you look at the definition of the functional statements.
Yes,
And
sounds
what's the
great.
definition of F92?
Okay, sounds great.
You found it? Okay,
Yes,
great. Thanks. Okay,
thank you.
Rahman. You're welcome. So we know what are the systems and the materials that are assemblies components associated with thermal designs. We know where to look out for heat transfer and thermal performance. We know that the code will send us back to some parts in part 3 for some the design of the firewalls, for example. We're looking at when we're looking at the design of for plumbing facilities, we go back to part 7, and we're looking for some of the occupancies. For 3.7, we're looking at that. For barrier-free design, we have to go to 3.8. And for environment separations, we can always go back for performance. We have the option of going to part 5. So some of the systems designs that need to be done to part 6 in equipments and installations. And for houses, we know for energy conservation, for energy efficiency, we have the option of using the performance compliance, and there's documentations required with it, and it's limited that modeling performance, comparing the passive house or the reference house to your actual house proposed. In terms of you compare the performance of it, those modeling provisions are allowed for houses and houses with secondary units only. You can always go to use the National Energy Conservation code, and you can for all for all types of buildings. And for some buildings, you can also you can apply for some of the designs you're required to use, and you're permitted to be using the provisions in 9.36. So structural design also, there is limitations on structural designs. You've got the option of using part 4. You're using some of, if you can use part 4, you may use part 4 with the loads and specifications in part 9, but you or in part 4 you have that option, or you use the specification and the span tables in part 9. So these are, it's a combination. So the building codes work harmoniously between the volume 1 and volume 2. You don't use part 9 independently of volume, and then the rest of the parts in the building code. Hopefully that gave you an overall idea of how to navigate the building code, how to look up for provisions related to the building code. Remember that your first thing is to look for the table of contents. Remember that you have your applications and limitations. You remember where to look up definitions. Sometimes there are specific definitions, and we found in part 9 that are applicable for the specific subsections, that we use those terminologies. So make sure you put tabs in your books and or binders to identify the critical tables, critical appendices to use, tables of contents, and major divisions, major parts, some critical sections that you need to be that you feel like less comfortable with in terms of design. So that's my approach to the building code. I shared it with you. We don't have time to go into the application and reading all the code requirements in 2 days. And I appreciate your feedback on this approach of teaching the building code. We look forward to your comments. We look forward to your feedback, and everything that you share with us will contribute to improving our service and our rendition for training students and interns and to prepare for the exec. So with that, I have we still have 5 more minutes. Camille, do you want to contribute unless I have a question for anyone?
I will wait for questions first, and then I can come back after, yes.
Okay.
I have a general question.
Go ahead, please.
So when you're approaching building code analysis, specifically with part 9, do you have a matrix, or how would you start if you were hired to?
I mean, there is the matrices. I think it's part. I mean, the RAIC. I think. Correct me if I'm wrong, Camille. Don't you have matrices for both part 3 and part 9?
Yeah, I guess that would be part of the CHOP. But
Yeah.
is that the way that you would approach?
I would approach it that way. That's my approach. And
Okay.
then yeah, that's my approach. I would, we've gone that a little bit when we looked at part 3. You got to look for what are your occupancies. Always look what are your occupancies. What are the wishes of your client? Maybe your client does not want a wood frame building. Maybe he wants a steel frame, non-combustible frame buildings. So establish the requirements of your client, right? I mean, that's what he wants. If he sprinklers or not, sprinklers provide additional protection, and also you can get out, there's exemptions for buildings that have sprinklers in them. So see what is the feeling related to sprinklers, or make the recommendation of using sprinklers. We're fire protection engineers, we always recommend that you installation of sprinklers, but the code does not always require one. And when it doesn't require them and you install them, it gives you leeways and less restrictive and less and less requirements. So there's trade-offs there. So know your occupancies, your major occupancies, know your construction of the building and what the client wants, and then determine, and based on what you are designing for the heights and the areas and the grades, you know what you're dealing with in terms of floor area and heights of buildings and number of stories, and from there on, just look at what other fire protection systems are required, what are your exterior exposure, and you'll be working with the mechanical, electrical engineers, right? I mean, they will take care of the compliance of the electrical mechanical systems. For energy efficiency, you need to decide which, for residential and Part 9 buildings, you need to decide what you want to use in terms of approach for compliance. And for plumbing fixtures, you've got the options of certainly you use the requirements of Part 9 and 3.7 for other occupancies than dwellings. So that what else? So I would use the templates. My approach is always use the matrix, start from there, but know what are if the use of the sprinklers is a possibility, and know what kind of construction that you're going to be using. If he wants to use non-combustible in accordance to code, then you want to make that put limitation of what kind of products you're going to be using in your building. If you're using combustible construction, there's more flexibility there in terms of what material you choose and specify.
Okay, thank you.
Yeah. And of course, you've got your on your site plan, and this is where you work with the civil. You've got your you look at your access roads, and you look at property lines, and you look at what if you're using for the garage, how you're going to consider the garages for basement. If you have basement garages, are you going to consider it a separate building? Are you going to consider it part of your building? So that's another major question that you kind of deal with right away, in addition to accessibility for fire department to your buildings. Any other question? Camille, you have 1 minute.
Well, yes, I just want to take a couple more minutes before we wrap up, especially to thank you, Amal, for sharing your knowledge with us, and to thank you all for participating in this weekend's NBCC Part 9 webinar. As Amal said, please take a few minutes to complete the feedback survey. Your comments are very important to us, as we want to give you the best content and experience at all time. The recordings will be made available through the LMS 5 to 10 business days after the event. We will send you an email to let you know when they will be available online. To receive your certificate of completion, you will need to complete the 4 quizzes and the feedback survey on the LMS. And lastly, if you are interested in any other upcoming continuing education or past webinars, we invite you to visit the reic.org/continuing education. And yes, thank you everyone, and have a great rest of day.
Hey, thank you, Camille. So what I'm putting right now for you guys is just make sure that you have my email visit. So
Amal, I think we lost you. I can't hear myself.
Yes, you are very fainted in the back, Amal.
oh, sorry about that. So
There you
here.
go.
Yeah, so I'm just putting my my email address if you have any questions on the quizzes.
I have a simple question about, like, I missed part 3. Will there be any other section for part 3?
So yes, the part 3 is also available through the LMS. If you would like, I will enter my email in the chat box, and please send me an email. I can direct you to part 3.
Yeah, yeah. And as I said, so feel free to contact me if you have any questions related to the quizzes, and good luck to everybody who's taking the exam. I don't know when it is, that's up in the air, but when you do take it, good luck to you, and hopefully you'll be prepared, and we have prepared you well to be able to succeed in it. So good luck to everybody who's planning on it.
Will there be any additional quizzes, like, available for us to practice?
No, these are the 4 quizzes that we have on this, plus there's the 4 quizzes on part 3. So these are the only quizzes that we have.
So
I
it's
also have a question.
Go
I
ahead.
missed part 3 as well, but I think I'm
Yes.
going to order that one. But I was just wondering, I can't find that illustrated guide online anywhere for part 3. I found part 9 on the website that you gave us, but
Oh, the 1995. They have the guides. If you go into let's see here. Let me show you where you're looking for part 3, 1995.
yeah.
NBC 1995 guide. This is National Building Code. What is that? No, it's puzzle. This is guide. All right. 2015 to 1995. Part 9, part 3. There you go. So here it is. Okay.
Okay, thank you.
You're welcome. Anybody else? Anything else? Okay, guys. Maher, do you have anything? Are you still an open mic? You're fine?
No, thank you so much. Thank
Okay.
you.
So you've got the links for both illustrated guides. Thank you very much for your participation. Thank you for your patience as we go through screen to screen, document to document, and again, please give us your feedback. That's the only way we can improve ourselves. It's knowing your feedback. Okay. Have
Okay,
a
thank you.
good evening, and thank you very much again.
Thank
Bye.
you. Bye.
thank you, Amal. Thank you,
Good.
Camille.
Thank you. Thank you.
Bye.
Thank you.
Thank you. We hope that you've enjoyed this session. For additional continuing education opportunities, visit the www.raic.org/continuingeducation.